Hello, good people. I got a request to make a video about IVP initial value problems, and I'm gonna give you three examples. So, first example is y double prime minus 6y prime plus 5y equals 0, and y of 0 equals 1, and y prime of 0 equals negative 7. So, first of all, we're going to look at the equation and just forget it. We're going to forget about this part for now and just solve the differential equation. And we're going to get y double prime. We're going to get clearly the characteristic polynomial is going to be r squared minus 6r plus 5 equals 0, which factors r minus 1, r minus 5. And that gives us a solution, y equals x1 times e to the x plus x2 times e to the 5x. And this is pretty standard. This we've done a whole bunch of times in class. Now we're going to make use of the initial value thing. So this is the general solution with the k1, k2, and k1 and k2 could be anything. But now we want a specific solution. I'm not sure if the right word is specific or particular, but whatever. We want a solution that not only makes this differential equation true, but that has these conditions, satisfies the fact that y of 0 equals 1 and y prime of 0 equals negative 7. So I just want to find the right k1, the right k2 that's going to make these guys happen. So I'm going to just basically take these values and plug them in. But before I can do that, I need to find y prime. So if y is equal to k1 e to the x plus k2 e to the 5x, I just got to differentiate, and I get y prime is equal to k1 e to the x plus 5 k2 e to the 5x. Now I'm just going to take these values and plug them into these two equations. And what am I going to get? Well, I'm going to get, here I plug in 0 and 1 for that guy there, and here I'm going to plug in 0, x is 0 and y is negative 7, which is for that condition there. So k1 e to the 0 plus k2 e to the 0 equals 1. k1 e to the 0 plus 5 k2 e to the 0 equals negative 7. And this leads me to basically two, what do you call these things? Simultaneous linear equations. Stuff you do in algebra. Stuff you did in algebra a billion times. k1 plus k2 equals 1. k1 plus 5k2 equals negative 7. Again, this whole thing got down to just a simple algebra system of equations, and you can, using your algebra skills, you very quickly and easily get k1 equals 3, k2 equals negative 2. I'm sure all of you did that very easily, and that gives us a solution now. That gives us the final answer of y equals 3 e to the x minus 2 e to the 5x. But I don't want you to believe me. I want you to take this new solution, and I want you to check that it goes into the original differential equation, and I want you to check that it satisfies y of 0 equals 1 and y prime of 0 equals negative 7. This is something I want you to check, and then upload your results into our checked answer folder. Okay, that was example 1. Now we're going to look at example 2. Y double prime plus 8y prime plus 16y equals 0, and we're giving the initial conditions that y of 0 equals 17 and y prime of 0 equals 48. And all we're going to do is, again, we're going to, similar to what we did before, we're going to solve the differential equation to get a general solution, and that's going to give us a characteristic polynomial of r plus 4 squared equals 0. We get that from here, and which gives us a solution, as we've learned, of y equals k1 e to the negative 4x plus k2 x e to the negative 4x. And now all I got to do is, just like I did before, I'm going to plug in these values into this equation and get my answers. But since there's a y prime over here, I need to take y prime here, and that's simple. Again, just straight by taking the derivative of each side, this becomes negative 4k1 e to the negative 4x, and that becomes k2 times 1 minus 4x e to the negative 4x. I just wrote it this way. I liked it better. And now I'm going to plug in the values of x equals 0 and y equals 17, or y prime equals 48, and just solve for k1 and k2. And we're going to get down again to a very straightforward linear plain old linear equation. Not a linear differential equation, but just a plain, which this happens to be, but just a plain old linear equation. So we have k1, basically this becomes k1 times e to the 0 plus k2 times 0 e to the 0 equals 17, and negative 4k1 times e to the 0 plus k2 times 1 minus 0 e to the 0 equals 48, and it's very, very simple to solve that. I get k1 equals 17, and K2 equals 1/16. That's a very simple, from this very simple algebra to get that. And that means that my final answer is going to be y equals 17 e to the negative 4x plus 1/16 x e to the negative 4x. Again, I want you to check this, that A, that this solves the original differential equation, and B, that it satisfies these conditions. And that's what I want you to check and put into the check solution folder. And I promised you 3 examples, and here's the third example: y double prime plus 4y equals 0, y of 0 equals 0, y of pi over 12 equals 1. Now, this leads us to the characteristic polynomial of r squared plus 4 equals 0, which leads us to r equals plus or minus 2i, which leads us to the solution y equals k1 cosine 2x plus k2 sine 2x. And again, this is something I learned how to do for this. This is, by the way, did anyone notice I have a case 1, a case 2, and now I have a case 3? Get it? Anyway, now I'm just going to take my initial values. Now notice this is a little bit different than the previous problems, because instead of having a y of 0 and a y prime of 0, which I had before, they're both y's. Y of 0 equals 0, and y of some other number, pi over 12, equals 1. So it's a similar type. It's similar, but a little slightly different. So I don't have to do that step of differentiating my general solution to get y prime. I'm just going to take the 2 different values and put them in the same equation. So when I put in y of 0 equals 0, I get k1 cosine 0 plus k2 sine 0 equals 0. When I put in y of pi over 12 equals 1, I get k1 cosine pi over 6, because it was 2x, and k2 sine pi over 6, because it wasn't sine x, it was sine of 2x. Anyway, this very simply leads to k1 equals 0, k2 equals 1 over sine pi over 6, which is just equal to 2. So my final answer is going to be y equals 2 sine 2x, and that's this is the whole thing, this is the whole problem, and it all works. I'm going to take a snapshot of this and put it into our little folder, but this is the good. So anyway, my point is, this was done by a request. Someone wanted this extra video, and I made a video, and it's a very good idea. If there's anything you'd like me to make more video, I'm always making videos anyway, but if there's a specific thing you'd like me to make more videos on, or any videos on, let me know. Just like the person who let this. Now, I'm not mentioning the person. He who shall not be named, but this is a great video. Anyway, I'm out.